time to join the session. I guess other people will also join, or they were here and they left because we started late, but they will catch us as we continue. Please also make sure that you engage with the presentation and ask questions if there are any questions that you want to ask Chris. And before we even start, I want to also read Chris's and introduce you to Chris and read his bio. Okay, just give me a second to pull it up. Okay, so Christopher Mucheka is a data engineer with experience from fintech, retail, and technology startup. He has worked as a data scientist at Sirite Insight, a data analyst at ShopRite, a data engineer at Pick n Pay and Onzi. He is skilled in Python, SQL, PySpark, AWS, Snowflake, modern ELT tools. He also specializes in building scalable data pipelines, ensuring data quality, and delivering analytics-ready data sets. Chris is also passionate about mentoring, and he also helps teams adopt best practices in data engineering and observability to drive trusted, data-driven decision-making. And ladies and gentlemen, let's welcome Chris as he talks to us about data quality and observability. Over to you, Chris.
Thank you very much, Elizabeth. So today we are going to talk about data quality and observability in action. So as Elizabeth has done the introduction about me, I'm a data engineer. Currently working at an Onzi, which is a fintech startup company. I have various experience in different roles: data scientist, data analytics, and currently data engineer. So my path into data, it's actually started in a way that I had not planned when I finished my metric. Apparently, I wanted to do pathology, but then God had his own plans. So I'd applied for only pathology and I didn't get any place at DUT and UKZN. Then when January came, I didn't have any place. Then I went to Water Sisulu with my results as a walk-in. Then when I went there, I was like looking for any course. Then they saw my results. They were like, you did well in mathematics. So there is space in BSc mathematics. Then I went there, then I did register. So when I registered, I had majors with maths and statistics. Then some electives which were like computer science. That's where I grew the love of technology, programming, and statistics. So with those skills, I wanted to actually solve real-world problem using my programming skills and also statistics. So that's how I ended up being in data. But then when I was in data, there are different roles that are there in data. So I started working as a data scientist at Sirite Insight, where I was actually building some models, machine learning models. Then when I finished working on the project that I was working on, then went to ShopRite as a data analyst, where I did a lot of analytic works. While I was doing analytics work, there was some data engineering thing that I started working on. That's where I actually fell in love with data engineering. So now I'm into data engineering. So enough about me. So now about the data quality. In each and every organization, they have data, they have information that is stored and that they want to use or utilize to make decision. So for them to actually use that data, they must actually have trust in that data. So why data quality matters is because it matters because each and every dashboard, which actually give business stakeholders insights, each and every AI model that you want to use, and every decision relies on this data. So this data must be of high quality because a lot is on stake. Each decision that is made based on the insight, based on this data, uh, so it must be of high quality, and if the data is poor, then the decisions which are made are not gonna direct people into the right direction. So the business is at risk of making poor decision or bad decision, which will actually impact in terms of its growth, revenue, and profits. I'll give an example because I've been working in a retail. So yeah, in the retail space, they use a lot of data in terms of like promotions, campaigns, who to target, at what price would they sell their products. So if we have wrong data, for example, there is data about people who purchases Pampers, right? Then if our data is not of quality, if it's missing key features and key fields, or if it's actually incorrect, then it means that we are likely going to promote our products to the wrong people. You end up promoting to people who don't have kids, in terms of like if it's Pampers, or people who have actually who don't have kids, or who are not even planning to have kids. So that promotion that they already that they will do, or that they will run based on the poor quality of data, will actually cost them a lot. Then in terms of the data, I mean, data at this point, or in this age, AI age, it's very important. We can say data is actually gold, and as you know, people who are in mining, gold, it's it goes through stages to be purified, to be cleansed and refined, so that it's of higher quality. It's just the same as our data. It must be purified, it must be cleansed, it must be refined, so that we actually have the quality of data that is of higher standards. So we have some core principle of actually data quality and observability. So these are the core principle of actually checking our data quality. So we have accuracy, where we actually checking how accurate is our data. Does it reflect reality? I'll always give example of customer data, like in the retail spaces. Uh, do you see something whereby you find a customer with an age of 1,000? Is it accurate to have someone who is 1,000 years old, or someone who have a who is with 0 years of with 0 years of age? So those kind of things that people actually do when you are doing your data quality checkups. Is it complete? So whenever you're building data pipelines in databases, you have the R required fields. We have things like primary keys, foreign keys. So these fields that really matters to the business, they will have to be checked if they actually, when a person, for example, when you're registering a member, did this person actually have all these fields present? So does is our data complete? Then in terms of consistent, does the same values across systems? For example, you find in some case for gender, you have male, you have females. The next thing you find integers or double. Is it consistent in terms of how we actually capturing our data? Then you also have to check timeliness. Is our data up to date? You don't want to rely on data that is not up to date. For example, a data that was last updated in 2015. Can you trust those data pipeline that is not being updated? If it's for member data or customers that haven't updated their phone numbers or their addresses, are you going to trust the data that hasn't been up to date? Then in terms of trustworthiness and governance and ownership, this is where you'll be like checking who owns this data, where is it coming from, is it being kept in a manner that no one can actually make any changes to that. So if the data is not secured, it's accessible to anyone and anyone can make any changes, how can you trust such data that anyone can actually make any changes? Then we also come to observability, which is like where you're actually checking your anomalies, your lineage and flows, how the data is actually being moved from one place to another. Is there any anomalies, something that I've mentioned in terms of accuracy, where you find someone who has a member or a person that has age of 1,000 or age of 0 in a data of people who are purchasing things or item or products in the retail spaces. So these core principles of data quality and observability, we have to make sure that we observe these and cater for these when you're actually building your data pipelines. Then we move to the best practices in it's either Azure pipelines or AWS pipelines. So in the data engineering space, where you're actually writing ETL pipelines that actually ingest data. So when you are ingesting data, you have to kind of like look and validate the data before you actually load it somewhere else. You don't want to load something data, then you start investigating. So these are the practices that you have to make sure that you have in your pipelines when you're actually building your pipeline, that before you ingest your data, did you validate, did you check the schema? Are the fields that are required there? Is it stored in the right format? You check at like null values, duplicate. So this will help you to actually prevent errors when you're now loading your data into like your databases, your data warehouse, whereby you find your data pipelines, they are failing because probably there's a null value on primary queues or on values that are not supposed to be null, which you should have cached before you actually ingest the data. Then the other practice is to make sure that your column mapping is consistent in terms of types. The names, when you're talking about types, you're talking about data types, which is like integer, double, string, and make sure that each and every field that you are going to ingest in your ETL pipelines, they're actually mapping correctly to the correct fields and the data type. And this actually helps in terms of like solving the issues of schemas, whereby a field that is mapped to a wrong field, you will be able to to capture this and to notice this before you even run your data pipelines. Then we have to look at also the transformation and merge statements. This is like when you're now doing your updates or your inserts into different table to make sure that each and every statement that is going to be updated, before that, whatever transformation that is being done, it's actually doing what's supposed to do in terms of what's supposed to be updated and insert. You don't have to insert data in the wrong tables or where it's not supposed to be inserted. Then we move into error handling. How do you handle all these issues now that you will find in terms of quarantining the bad data, or are you going to just ignore it? Are you going to handle it? So the best way is to handle whatever errors that you find so that your pipelines, they don't just fail and you don't have any way of actually moving data, even if there is some issues. I'm going to present a hands-on on this error handling and quarantining the bad data. Then the other best practice is to automate data profiling. So what we mean by automate data profiling is where you don't have to do this manually, because whenever there is manual work or human interventions, that's where a lot of things are being missed, or a lot of mistakes are actually done. Then at the end, what you would want to do whenever you are building your pipelines is to have a monitoring dashboard or alerts that you actually receive. It's either through the Slack or Teams or email, so that you know when you are running your data pipelines that there is some issues that are happening on your database, other than to wait and hear from stakeholders that there is something that is not making sense. At this point, I just want to take a break and ask if there's any questions that you would want to ask. Okay. Then moving to the emerging threats and advanced considerations. So with data, if you're now having wrong inputs or data that is incorrect, that's kind of like poisoning your data or making your data to be data. So there is a say that say garbage in, garbage out. Imagine you're in a scenario where ChatGPT is being given incorrect inputs. When you're talking about malicious, we're talking about data that is dangerous for AI to be exposed to, in terms of like suicidal thoughts. So it end up let me say advising probably underaged kids, or advising people wrong advices because it have been exposed to incorrect data, or they have actually been given data that is malicious. So this, as you can see, the way these colors are, it actually shows how dangerous it is, or how those threats how those threats are actually emerging in this age. So moving down here, we have extended observability to data supply chains. So here is whereby the data supply chains is not observed, and we are not cleaning our data. We're just allowing each and every data to come as true as it is. This can be things like false news, where you train your data or your models based on data supply that is not being double checked. Then we also have to consider things like providing tools and controls. So these are the controls that I had mentioned, that you have to check how accurate your data is, how complete it is. So these are the measures that you have to actually put in place, because if you don't, then they're gonna be like a lot of threats in terms of how your data is. Then we have business defining the quality standards. So business should each and every business have its rules. So defining those standards and rules and put them in place will actually help us to overcome the threats. If those standards or rules are not put in place, or they are actually incorrect, then we're going to have threats, and they're gonna poison our data. Then the other is everyone should protect and use data responsibility. So whatever data you come across, you should protect it. The East Poppy Act, if it's not protected and you're not using it responsible, then the chances of you being sued or the chances of the business getting sued are very high. So these are the threats and the emerging threats that are actually coming in with the data and AI area that we are in. So at the moment, I'm just gonna share some of data pipelines and how you actually enable data quality in terms of how you build your data pipelines, how you observe your data qualities. So just gonna switch my. I'm going to share my screen so that we can go into some practical example. If there's any questions, you can ask while I'm preparing this.
There was one hand while you were talking. I don't know, Ntangaze, do you still want to ask your question? Ntanganezi?
Can you hear me?
Yes.
Yes, we can hear you.
So you keep on mentioning data pipelines. I just want to understand what is a pipeline? What is a data pipeline? I'm not sure if you explained this in the beginning, but I just want to understand that.
Okay, cool. I'm gonna explain it now. I'm not sure. So can you see the screen of my web that I'm actually sharing? Apparently, I can't see what I'm sharing.
Yes.
Okay, so this is DBT. That is a tool that is used to actually build data pipelines. That's the question that you asked. So
sorry, Chris, we currently seeing the presentation of the
all right.
That you're trying to display.
Okay, let me see. Okay, can you see now?
Yes.
Okay, awesome. So this is DPT, a tool that is used to actually build data pipeline. So a data pipeline, it's kind of like a code that you write to move data from one place to another. So there are different ways or different tools that you can actually use to build your data pipelines. So in DBT, the way you build your pipelines is actually through models. They call the models. So for example, Danganetsi. So this is what we can actually call a data pipeline, where you have your source data that's being ingested or being transformed through these models that you can see here. So this whole thing, we can call it a data pipeline. In DBT, they call it lineage, which is also like, yeah, a data pipeline. So you have your source data that get transformed. When you're talking about transformation, like see there, like we're talking about ETL, where you extract your data, you transform it, then you load it somewhere else. Or in this case, this is kind of like ELT, where you extract your data, you extract your data, you load it, and then you're transforming it. So DBT, it enable ELT instead of ETL, where you extract, load, then transform your data. So this is customer and order data. So I'm just gonna go to Snowflake where my data is. So from the Snowflake, this is a data warehouse where I'm actually storing my data. Then this is the so if you see where I was actually creating my data, so we have like some customer data here. So we have 3 rows of data. So if you look at the emails that you have, this is not a valid email. So when you're talking about data quality, we want to ensure that the data that we have is actually, as I said, it's actually accurate, it's consistent. So this person, if the business really value members or validate members based on the emails, then we shouldn't be able to push this data in our data pipeline, in our data warehouse. Because of what? Because we don't have a correct or a valid email address. So when you're building now your data pipelines, you must make sure that you cater or you check if there is certain issues like this. For instance, this person or this customer didn't have an email address. So I'm just gonna show you 2 ways of actually how people actually build their data pipelines. So I'm gonna start with this one, which is our staging customer. So in this way, we actually build a data pipeline where we actually pulling all our raw data here, then create a view, then we'll push it into the staging. So here we actually cleaning kind of like our data in terms of like we want our data to be virtual. We want to trim and remove excess spaces. And this is kind of like just cleaning your data. So in this way of building a data pipeline, it's actually trying to remove or make sure that everyone have an email that is valid. So I'm just gonna run this so that you see what will happen when I run this. So on DBT, when you're building or running your data pipelines, you click on build, then you need to run the whole pipeline. So you see here, it actually fails. Why is it failing? It's failing because there is data that is not correct. So the way I had built this is like, okay, so if there is any issues with our data, it must show that there is something wrong with our data. Then this error now will actually tell you, oh, we have an error. Then you will be able to what to solve it. But then there are issues whereby here it's actually giving you an error. What if the data pipeline was actually running at 2 a.m. at night, and probably you are not going to be there at work after 9? So how is it going to be for business stakeholders that likely going to use, for instance, in this, just maybe since this is the staging customers, there is fact orders, which is supposed to actually have data that have failed here. So which means our data here is gonna be what? It's not gonna be up to date in the morning, and probably there are some decisions that needs to be made based on that. So to solve issues like this, we actually have, this is the best way to actually build your data pipelines, where you have your clean data, your model. Then in your model you have another one that actually does what, that actually runs and actually store all those information or the data that have like issues. So here you're checking, okay, everything. We don't want anyone that if an email is, it's actually no, and we have an email that doesn't have the correct format, then we're going to store this data. Then at later stages now, you'll be able to investigate and make sure and investigate in terms of like, where is this data coming from? Is it probably someone who was trying to hack, or is actually the process of actually onboarding new members is actually wrong? So these are the issues, or the way you can actually use to actually make sure that the data that you have is actually incorrect. I'm not sure if you understand what I'm trying to show here. Is there?
I have a question, Chris. So when it comes to the error handling of data, what happens for instances where, say, column A depends on, well, rather, row B depends on row A. However, row A failed and row B succeeded because we are only loading data into a different environment. Do we then also just create one pipeline that's going to, I'm not sure if I'm using the right word, but do we write some similar logic that's going to do an extraction and find that error and skip the dependencies, or are we going to load with or without a dependency and figure out the issue later?
Okay, that's a good question. So in terms of when you are dealing with critical data, if it's actually critical, when you're talking about critical, it's like there are a lot or there is a lot of dependence on this data. Then in that case, you can't skip it. The reason why you can't skip it, because if you skip it, which means your insights are going to be inconsistent. There's now a lot of inconsistency now that you have ignored or skipped. Let me say, for this example, now that you have skipped, let me say there is a critical field that depends. If it's actually a field now, then it's going to be a big problem, because now if the field, probably using it for a join, which means how you're going to link those different models is going to be a problem. It's going to give you an error. I don't know if I'm making sense there.
Yeah, it makes sense, but I guess then it goes down to the decision of what's more important,
Yes.
killing the entire workload or only skipping and breaking your insights. I guess it depends.
Yeah.
Thanks.
So this is what I did mention, whereby business, they have to. Let me see if I can say. So business should actually define the standards and the rules. So if the business cares about certain things, then it's something that you can't skip. You have to probably fix or handle.
Yeah, makes sense. Makes
Yeah.
sense.
So in that manner, then it actually in that scenario now, it's whereby how data will actually enable to solve problems within business processes. For example, now if, in this scenario where the email address was not valid, which means either you have to now to go to like the software engineers to say, okay, guys, on your form when someone is registering as a customer, what these are the fields that we really care. They should be able to put filters in the first place that a person can't go through with such an email.
Okay.
Yes.
I know that makes sense.
Yeah. Any other question? Okay.
Yes, Chris, I have a follow-up question.
Yes.
It's a follow-up question to Nhlanhla's question. Generally, I think I'm answered in terms of to say how you handle malicious data or missing data is dependent on business decisions, right?
Yes.
But in this example that you have, let's say a customer didn't have an email like this. How would you handle it? Because I saw in other columns, in other tables there, you have the very same customer that you have skipped. He has orders, right?
Yes.
How are you going to handle this one? This specific case?
So it goes to now investigating how did this person ended up being in our database. So the first thing that I would do is actually engage with the engineers, the software engineers, to be like, okay, what's the process? Is the a filter that or a way that you use to actually enforce people to when they're actually registering, to make sure that that email is an email that is valid. If they say that they have, then we have to try to figure out where this data is coming from. Now we're now checking our sources. We're checking how our databases were actually created in the first place. So it's now becoming investigation. If we see that our processes of onboarding a member, it's actually it doesn't allow a member in that, then we have to delete that member. Probably there is probably it will be a hacker that we have had access in our databases and using that to commit probably fraud.
Okay, so it means to say the orders that are linked to that very same customers will be discarded as well. Yeah, based on the investigation.
Yeah, it's not based on that.
Okay.
In it will also depend with the business rules. What do you do with certain data when there is a possibility of fraud? Do you discard data? In this case, I don't think there is a possibility of discarding the orders. The only thing that we can actually delete is actually that member. On that member level, you can actually delete, so that probably they are using that to actually log in as a member and actually end up making those orders. Probably they found a loophole. So you wouldn't delete such entries because probably you want to keep records to be like, okay, these are the fraud transactions that we had in 2015. These are the insights that you'll be using now to be like, okay, these are the transactions that we actually ended up having. And in that case, you're looking at if your fraud insights are actually going down, or the number of people who are committing fraud or actually going down or not, then those are who actually end up using this information to make like decision to say that, okay, let's change our process based on the number of fraud or these kind of members or orders that we're actually receiving from people who don't have emails that really make sense.
Okay, thank you.
Yeah.
Answer?
Yeah. So I think I did explain that the way of actually building pipelines. So now this, when you're actually building the cleaner one version, this is whereby you actually have your you actually have your rules. Now in this is how I would actually make sure that I actually test. So when I'm actually building that customer clean model or data pipeline, first thing before I even load it is to make sure that I test the emails to say, okay, it's not now, because you don't want the customer that doesn't have a now email, or you also want to check the validity of that email. Is it that email, is that valid or not? So these are the things that I would actually put into consideration before you actually have your data or your model to run. Okay. All right. Let me share my.
Okay. Are there any other questions from the team? Can I ask Chris?
Yes.
Before you close, in terms of what you just presented, I know this was not part of your talk, but in terms of AI,
Yes.
And in the space that you are in, where you're building models and cleaning up the data and looking at the quality of the data and observability of the data, my question then arises in terms of what are the opportunities, especially with AI automation? Have you start venturing into looking at what are the kind of AI models that you can build to enhance or to assist with data quality challenges? And if so, can you just give us an example of where you used it? Thanks.
In terms of data quality, checking those things, it's difficult to integrate with AI because of how our business, the business rules that we have. Probably AI doesn't, it's not exposed to such. So and because of how AI is not yet matured to the extent of handling each and everything, and also the expenses, the cost that it actually is involved in integrating, let me say, ChatGPT into the data pipeline. It's expensive. There is a risk of your data security, how your data governance with AI. there's still fear within organization to expose data to AI in terms of like using the models that are there right now. People are still in the stage where they fear to expose their data. Where's their pipelines? So at the moment, we in most of the organizations that I've worked, it's a place where we be like, we should be careful with our data. So the data governance of most of organizations, they don't allow people to expose data because they fear copy act if there is a data breach and they realize that the data was being exposed to AI models like DeepSeek and ChatGPT, who actually cause chaos, or it will come with cost within the organization. So yeah, those are the things that organizations are very hesitant to do at this point. I don't know if I answered your question. So what is the skills in tech stack in data engineering right now? It's if someone wants to go into data engineering, you must be comfortable working with SQL. That's the first or basic skill that you should have. You must be comfortable working with SQL. You must have some basic understanding in Python. Then you also have to know cloud, how to use your cloud, your AWS, your Microsoft Azure, your GCP. Now you're now looking at Snowflake, you're now looking at DBT, Databricks. So if you know your SQL, Python, and have basic understanding of cloud, then as a beginner, you'll be able to navigate yourself. So I'm answering to the question that Dini asked. What are the hottest skills in tech stack data engineering now, typically for beginners?
I have a weirdish question. So with AI, we know, especially with large models, you know that they may say the data is clean, but it does come with some biases.
Exactly. Yeah.
The most obvious one, I think, there was an instance. I'm not sure. Maybe let me ignore this. But let's say how do we control the biases, especially introduced by your data? And there are obvious ones where you can look at outliers and where your data sits outside the median, but more on the softer ones, let's make this example of misdiagnosis, patient misdiagnosis, ending up with issues. However, maybe they have similar symptoms, and then we end up with a bias that says, hey, if this diagnosis is done, you might end up with a patient dying. How do you take care of such biases, especially when we're dealing with large models?
I'm not really into building data models. In data engineering, it's usually data pipeline. I'm not sure if you're asking of like using models like the AI models that are there, like ChatGPT, DeepSeek, and others, how biased they are.
Well, no, I'm just speaking about models in general, not the ones that are already there in existence. In terms of training, maybe even besides looking at actual models, but just looking at how do you preserve data knowing that it stays as truthful as possible, however, it carries minimal bias.
Okay, I think it's something that I did mentioned in my slide in terms of making sure that where your data is coming from, understanding the flow and the lineage, where your data is actually coming from. Is it a reliable source? How trustworthy it is? Is it being governed and it have proper ownership? Yeah, I'll give you an example. Imagine you want to build a model, right? You want to train your model. You find probably a model it's based on people purchasing behavior. Then you find a CSV file with data of people who have purchased certain products, and you just take it like, oh, okay, this is just like data that I can actually use to train my model. First of all, you don't know who the owner of that. You don't know if it's being kept secured in terms of no one has access to just like make any entries within that data, and to also ensure that does that data reflect reality. So these are the qualities that or the principles that you have to use whenever you're going to use your data, like how accurate it is, how complete it is, how trustworthy it is. So by following the core principle of data quality and observability, it will help you to have that confidence or remove the biasness of making such issues.
Okay, understood.
Any other questions?
And
Okay,
last
so
one from my side, Chris.
yeah.
Is data engineering is it going to be disrupted by agentic AI? Like, are we going to see agents writing pipelines anytime soon? No.
No, it can data engineering. It's someone, or it's a role that is between the software engineers, the data analysts, the data scientists, the machine learning developers, whatever you call it. As a data engineer, I interact, I communicate within different teams and make sure to ensure that our data is accurate, it's consistent, to make sure the governance is being taken care of. So the only thing AI can do is to reduce the number of engineers or data engineers. Either way, it will only the only thing that it can do to most career in IT is to reduce the number of people, because now instead of me as to have 5 data engineer writing data pipeline, it can only speed up the way I actually build my data pipelines. Not that it can do that, because what usually happens in organizations for data engineers is whereby the software engineers, they make changes, let me say from the front end. Let me say for that example that I showed you of the emails, they make a change in the front end or in their process of onboarding a new member or new customers. Probably someone removed a certain part of the code that actually validates someone's email. That change, now I'll be able to pick it up and go back to be like data engineer, to software engineers. Guys, we see that there are people who are being registered without valid emails. can you check your processes in terms of how you onboard someone? And this is whereby now they have to go and check and make sure that, okay, their process is actually correct. And if there is a bug, then they will actually correct it. It's now the data that is helping to actually fixing some of the processes in the business. So if I don't think in AI have that capability of being able to communicate within teams and resolve issues that are complicated like that. Yes, Vuyo.
Well understood.
Vuyo.
Oh, hello. I wanted to ask about like how exactly you broke into like the field of data, because I saw you said you started with data science. Like, was it a full-time role or was it a grad program? And like what were like the minimum skills that you had back then that allowed you to like to get into that role, and like your degrees and stuff and your projects?
So I'd how I started working on that project, it was based on a personal project that I was actually working on after my postgrad. So I did postgrad in data analytics and business intelligence. So it's based on the project that I was actually building, which showed the guys that I ended up working for that I had the skills to actually build something. So in terms of the skills that I had Python skills, I had understanding of the machine learning, and also the statistics. Those are the skills that I had at that time. And in terms of cloud, I didn't have any experience working in cloud. So I had to learn on job.
So was it a full-time role or was it an internship?
It was a full-time.
Okay, thank you.
So yeah, to just so when I was doing my postgrad, when you're doing your research, you had to do internship. So you have to do your internship while you're doing your practical. Like you have to be a practical, hands-on research. So that's when I did my intern. Then after that, I was doing a side project that I actually presented, and the guys that I ended up working with, they liked it. So it's very important if you want to break into this data engineering or data space to have kind of like a portfolio or some work that you actually do on the side, not only to have a CV.
Yeah, Chris, not to discourage you, right? You can actually build that portfolio of projects that Chris is talking about by yourself through self-learning. There are a lot of platforms, there are a lot of blogs you can use to build your data engineering portfolio of projects and break into the field.
100%. Yeah.
Thank you.
Yeah, just to wrap up in our key takeaway. So whenever we're talking about data quality, we're looking at how robust your pipelines are, how secure and how trustworthy they are, in terms of how they actually make the data to be of higher quality, for the data to be accurate. That's one of the most important thing that data quality observability will actually help you to actually build robust pipelines. And in terms of that, data quality, it should be a habit, not just a project. So whenever you're building a data pipeline, you must have in the back of your mind the core principles of data qualities. And you should make sure that you observe it when you're actually building that, not only to have one project that has it. Then in terms of the cost that you have to pay for bad data, sometimes you don't see it when the data is small, but then as data grows, the cost can be very expensive in terms of how you can make a bad decision based on the data. It can be really costly. Then in terms of how you can make sure that your organization have proper data quality, you should focus on automating monitoring and governance in your data. So what I mean by that is, like, if your data pipeline, they are automated and there's consistent monitoring, and you have your governance in place, you have alerts if there's any data that is that doesn't pass your test. Your pipeline should either fail, not just accept each and every data that comes through. So these are the tests that you must put so that your data it's good. It's actually of higher quality. Then yeah, that's it in terms of data quality. I think we did have some questions. I don't know if there's any other questions. Yes, Buyo.
Last question. I wanted to ask, like, in the workplace, how exactly like, what do you call them, the data warehouses, how are they like populated? Is it like through web scraping, or is it like through like getting it from like a form of a website? Like how exactly is it like populated?
Okay. I'm gonna share something in my screen. Maybe I didn't really touch on this. So your question is based on how your warehouse it's actually populated. So on this data pipeline here that you see here, right? This is how you'll be building probably a data warehouse. So in this case, I'm actually just showing you one data pipeline that is actually just showing or populating orders only. In an organization, you have customer data, you have employees data, you have events. When I'm talking about events, you're talking about like what people are actually doing on the website. People are being tracked in terms of like, okay, this person, they logged in, this is what they did, they purchased this, they clicked here, they canceled this is where they drop off. So in most organizations, they have different tools that they actually use to do data mining or to capture or to collect data. There is some tool that I've worked on in a certain organization called Postwalk, which is a tool that is used to track and record each and every session and each and everything that you do on a website. Let me say I'm on their website right now. It will be able to track even the way my case is actually moving. Each and every place that I click, if it's a button, it's actually recorded. So those events, it really means something to that organization. So it's actually captured and stored somewhere. So all those data, they end up being in data tables. So it's usually used, you have the source, probably that source is coming from, let me say that product, which is called Postwalk. So you have probably like another data pipeline coming with Postwalk data, which is like all the events, and those all events will be connected to probably like a member or a customer. Then you'll be like, oh, this member, he spent 50 minutes on their website and they only made five orders. So they can make decision to be like, okay, this is the time that people are spending on their website. This is the area that they're actually cleaning. So yeah, there are different ways they actually collect and process that data into the data warehouse. So I'm not sure if you know the difference between data warehouse, data lake, and a database.
No, can you explain it?
So for instance, this is the database, right? That have raw data. Then now here we actually process it into a data warehouse. So in this case, our data warehouse we actually creating using Snowflake. So this is where I'm actually building my warehouse in. So warehouse, this is where you now have aggregated data. A database, it's probably just a table or data that is being stored. Then a data lake, it's usually where you just dump your data. It's only that I don't have this. I was just playing. I was just using Snowflake. I would have showed you probably AWS, Amazon Web Services, where you actually build your data lake, where you just pull all the data and store it without being processed, or sometimes you do a little bit of processing it, but then the aggregated data now, it's where you're not actually pushing it into the data warehouse.
Thank you very much, Chris, and thank you very much to all the participants who are on the session. I think, Chris, your session has sparked a lot of discussion and debate, and I think people are more interested in finding out more, because I think the minute you went too technical and shared your screen and showed people all these and the pipelines and all that, so it sparked a lot of conversation and discussion. And I take one of those questions in the chat that talks about what are the skills that people need, or the type of technical stack that people need in order for them to get into the data engineering space as well. And I think that would require another session where we go into this in more detail, and especially also clarifying those type of terms in terms of what a database is, what a data lake is, and all that. It can take a session on its own, and I'm also mindful that we are 20 minutes over time, and I don't also want to waste more of your time. So on behalf of Pambili Analytics and the mentorship program, I would like to say thank you for sharing with us all your insights and for contributing your knowledge and imparting that knowledge with everyone who joined this. We truly appreciate what you've brought to the discussion as well. And we hope that from now on, you will be coming on board and sharing more knowledge with the participants as and when you have the availability as well. And to all the participants online, thank you for taking time out of your busy schedule and on a Friday, Nochal, to be here and to listen to Chris to share. I hope this session was worthwhile. Please, let's give Chris a warmly online virtual round of applause.
Thank you, Chris.
And Chris, I guess by show of those gratitude, it really shows that you did deliver and you did assist them to get some insights out of this session. And on that note, I will declare this session over. Thank you very much, and see you on another session. Thank you.
Thank you very much, everyone.
Bye.
Bye.
Goodbye.